For this project, we were asked to make either a photophilic or a photophobic car, which means mine was photophilic, which means it's moves toward light, is attracted to light. And so here's a picture of my circuit, and it is based off of three key components, or four. One of which is not labeled, but the first most important is the transistor, labeled in blue. Next is the photoresistor, labeled in red. And third is the potentiometer, is labeled in green, of these blue things. And then fourth are the motors, are pretty key to make the car move. But so basically, just a general kind of explanation of how this works is that in the center of my circuit, kind of the most important part is this transistor, labeled in blue, this black thing. And the way it works is it requires a certain amount of voltage to turn on this switch. And if there isn't that amount of voltage, then the circuit keeps going past the transistor and into the potentiometer in this case. But if there is that certain amount of voltage, it redirects the current to, in my case, the motor. So it's basically a switch, and because we have a photoresistor, which is something that's reactant to light, changes resistance based on how much light there is. When there's a certain amount of light, the transistor will switch on and power the motor, but when there isn't a certain amount of light, it won't switch on, if that makes any sense. So because my car is photophilic, it's attracted to light. So when there is a certain amount of light, the motor turns on. And yeah, so that's basically how my car works. But so to get into detail more, there are two holes at the bottom of this car. On the bottom one, you can see a red and black wire come out. So the red and black wire come out, and there are two 9-volt batteries on the bottom. So one of them is on the bottom. I just explained that. I don't know, I'm repeating myself, but it goes into this first hole, and then we can see a long red wire reach out. So that the battery is connected, the positive charge of this battery is connected to that long wire that extends out the bottom. And that red wire is connected to the photoresistor. So again, a photoresistor gains resistance or loses resistance based on how much light there is, and it loses resistance if you shine light on it, and gains more resistance if there's no light. So because my car is by the way, the photoresistor on the bottom is tilted to the left, like the photoresistor for the circuit on the left half of the car, the bottom of the car is tilted to the right, and the photoresistor on the top half or right of the car is tilted to the left. And this is because when I shine light over on the right side of the car, the opposite side of the car, I want the left wheel to start working. So if you shine light, if you're looking at the car straight on from where this photoresistor label is, if I shine light to the left of that, I want the right motor. I want it to turn towards that light. So I put the photoresistor on the side that I want, on the side that the light's coming from, and then the wheel that works is on the opposite side, if that makes any sense. But so that photoresistor, when it gets light, loses resistance, and the battery, the voltage comes in through that photoresistor at a low resistance, and my circuit is set up in a way so that the ratio between the photoresistor and the transistor, the voltage ratio between the photoresistor and the transistor and the potentiometer, equals 9. So that's why I needed an adjustable sort of resistor, which is potentiometer, to make sure I could adjust it to the right kind of ratio. But anyway, I feel like I'm just jumbling words here, but the transistor, once it gets a certain amount of light, turns on the motor because the voltage, it fliches the switch, and the voltage goes out that other output that the switch on the transistor allows it to go to, and it turns on the motor. But so when there's no light, the car doesn't move because the resistance of the photoresistor is too high to turn on that switch, and the voltage just keeps going through to the potentiometer and then the ground. So yeah, that's pretty much how my circuit works. And here is, and then so that's just that was the bottom half. I'm just focusing on the bottom half, and the top half works the exact same way. And again, this is a really bad picture of my circuit, but it makes it kind of hard to explain. But that is how she works.